Hello all, my name is Narayan Annamalai. I'm a program manager in Azure networking team. I'm here today to talk to you about user-defined routes and how it can be used to host network appliances in your virtual network. So if you're interested in hearing more, continue watching. So we have a plethora of services in the Azure platform, and the one that I'm going to talk about is especially concerned with virtual networking that you see over here. It's an infrastructure service. That's something that you actually start with, and you can build on top of it with a lot of other applications or services. So this is going to be one of the fundamental building blocks. So before we actually dive deep into user-defined routes and how you can actually use it, I'm going to do a little bit of an overview of Azure's virtual network. So we think of the virtual network in Azure to be the representative of your network that you have in on-premises. So as you come to the cloud, before you start deploying your virtual machines or services, you want to have a boundary or a network for yourself. Just like how you would set up networking on the on-premises, you would also set up networking on the cloud, which is the starting point for that is your virtual network. So you will typically start with an address space definition. So if you want to connect your on-premise network and the network on the cloud, you'd probably start with a different address space. Once you start defining the virtual network, then you'll actually go and divide that into different subnets, then do the deployments under that, and then you will define security policies. So let me walk down that path a little bit. So here is a picture that kind of represents a very simplified representation of your on-premises network. So think of that, the outer box, which is called as the on-premises, to be representing your on-premise network. So it probably has an address space like a 10.1/16 or 10/8. You're connected to the internet through some routers, hardware routers. And on the first level of the front-end layer, you probably have web firewalls, and you have a DMZ zone where you host your web servers or whatnot. And then as you go down, your more secure servers like your database servers and app servers are sitting on layers behind your DMZ, and you probably have some hardware load balancers to give you high availability. So if you have something like this that is working on the on-premises, and when you move this to the cloud, to Azure, where would you start? How would you get the same representation? So if you see, in Azure, you will start with your network. That's you bring in a network. So like you have defined your on-premise networks, you will define a virtual network here. So you will define an address space. The next thing is this virtual network gives you a logical isolation, with control over your network, which means even though Azure is a multi-tenant cloud, we can virtualize networks for you. So we can provide an isolation trust boundary just for yourself. So you probably would need more than just that. So once you define your network, you will need to define your subnets, which is just more to provide more network segmentation. This virtual network also allows you to define your DNS servers. Azure automatically gives you connectivity to the internet. So anything that was done through hardware in your on-premises now is achieved through software-defined networking. So the virtual network here behaves like a layer or a casing for your deployments, and Azure can connect this virtual network to the internet using its own infrastructure. What you have as web firewalls in your on-premises, the same functionality can be achieved through mechanisms like network security groups, where you can define network security policies and you can apply that to different subnets. Hardware load balancers can actually be replaced by Azure's internal load balancer, which provide high availability for your services. So holistically, what we're trying to tell you, or what we're trying to give you, is the full-blown functionality of a network that feels and looks the same as your on-premises network, and that is what a virtual network for you in Azure is. So I'm going to talk a little bit more about user-defined routes. So in this session, I'll actually show you a hands-on example of how you could build a very simple virtual network with subnets defined and with VMs deployed in them, and actually define a route table and routing entries, and show you how to take control of the network, more so. So before we actually go into user-defined routes, in virtual network today, you can define subnets, like I've shown here. You can define front-end and back-end subnets, and you can deploy virtual machines, and they all can talk to each other. So that's because Azure provides you something called as system routes or default routes. So this is nothing more than, like, if you go into your virtual machine or into your VM on your on-premises, and if you can type route print or IP tables, you will see that how the VM is actually dealing with the packets, who is sending it to as the next hop. So Azure Virtual Network by default, gives you this default system routes wherein a virtual machine on the virtual network is directly connected to another virtual machine on the virtual network. So they are just one hop away, or rather they are directly connected. There is no need for this packet to go through several different hops. They are directly routed from one VM to the other. That is what you have. So most people don't need more than that kind of routing. They need the VMs to talk to each other, and the virtual network will give you that. But in some cases, if you want to do some advanced scenarios, wherein you want to inspect the packets that is flowing through your network, or you want to provide a common NAT functionality to NAT the packets before it goes to the internet, or if you want to do like a detailed logging or firewall application level firewalling, you may want to take control of how the packet flow is happening within your virtual network. And in this case, what you will actually need is to define a route which says which can take the packet from one VM and then gives it to another appliance of your choice, which could be a virtual machine, before it actually takes it to the final destination. So this is really injecting yourself in between the traffic flow or the routing. So that's what user-defined route is for you. So as I show here, you can just bring in another virtual machine and then you make it behave like an appliance. You set a flag called IP forwarding enabled on this virtual machine, and then you define a route table that says anytime you talk from the front-end subnet to the back-end subnet, the packet goes through this virtual machine. So this virtual machine now is where you can run any of your applications, which is you can either just log this packet or do more application level filtering and choose to drop the packet, or you can do some like a natting or whatever you want to do before the packet goes to the backend. So this is really user-defined routes. And today I'm going to be showing you a sample and a template which lets you do this or set up the whole scenario. So I'm going to be using the Azure Resource Manager template. So if, as you're familiar, Azure now has two deployment models. The model which is now called as the Azure Service model which was in effect for so long. Now we have a newer model, released like a few months ago, called the Azure Resource Manager. So, and this has multiple ways of deploying your resources into this deployment model. So one of the ways is using a template, which is what I'll be using today. So this is the demo setup going to look like. So I'm going to be in the template creating a very simple virtual network. I'm going to be further dividing the virtual network into two subnets, a front-end subnet and a back-end subnet. I'm going to be deploying a VM each in the subnets, front-end and back-end. And I'm going to show you that just by, the default route will take effect in the virtual network, and the backend subnet, the VM in the backend subnet can just talk to the front-end subnet. And then I'm going to actually introduce a route, a user-defined route, the UDR. I'm going to attach this route to the VM1, and I'm going to say any packet that you want to send to VM2 should actually go via or go through VM3. And VM3 is going to be another virtual machine that I'm going to deploy into this virtual network. And I will set it up as an IP forwarding enabled virtual machine, which means it acts like a router. and it will see the packets that is actually flowing between VM1 and VM2, and I'll show you that. So for the next step, I'm actually going to go to the template. Okay, so this is a template that I put together, which actually shows you everything that we saw in the previous slide. So I'm actually going to start here. Don't let this size of this template make you believe that this is complex in any way. This is quite a simple template, easy to follow, and I'll actually go through that, the necessary parts of this. So as you see here, the first section I'm going to go through is the virtual network section, the one that I've highlighted. So over here, I'm saying that I want to define, I want to create a resource of type virtual networks. And I'm just giving some properties to it. So that depends on is like, other resources that I want to be created before I create the virtual network. I'm calling out a route table and a security group, and I'll go over that in a minute. But in this template, I'm saying that, okay, I have an address space property. This is a parameter. The user can supply a parameter for this. So in this case, I'm taking like a 10.0/8 to be the address prefix for my virtual network. And the subnets, I'm defining subnets. So I'm defining a subnet 1 with the prefix. Everything is actually a parameter that I can pass to this. And to this subnet 1, I'm actually attaching a security group. As you see here, as I'm saying, there is a security group for this subnet. It's called as a default NSG. And there is a route table for this subnet, which is, again, something that I will actually go over. And that's subnet 1. I also have subnet 2. In subnet 2, you can notice that there is no route table. So this is a subnet I'm going to be deploying my backend VM on. So I just don't want any route table for this. I just will use the system routes. But in this subnet 1, I'm going to use the route table that I'm going to define. So I've attached that route table over here. Then I have the subnet 3, where again, I don't have a route table. I just going to have a security group on this. So that's all. That is all it takes to create a virtual network with 3 subnets in Azure. The next step, I'm actually going to show you some of the other resources that are more interesting. So first, you may want to think about the public IP address. So in the picture, I showed you like 3 virtual machines. In order for us to remote into the virtual machine to show you the demo, I'm going to request for public IP addresses for these machines. So I have a public IP address 1, public IP address 2 here, and public IP address 3 here for the 3 VMs. And then I also have a network security group. So if you have not seen this before, defining a security group is pretty straightforward. So I ask for a resource type, network security groups. This is under the Microsoft.network namespace. I just give it a name. I give it some properties. The properties are primarily security rules that I'm defining. So here I'm just defining the security rule that says allow RDP. So you can see that here that says allow, and then I give it a priority. Its direction is inbound, and I'm saying open 3389 from internet. So this security group, once I attach this, the virtual machines that use a security group will be open for the RDP access. So that's all I'm doing there. And then, of course, the security groups also comes with the default rules. The default rules are, it'll always allow communication between virtual machines in the same virtual network. That's a default rule. So I'm just not overriding that. I'm going to keep that rule. And then I come to the route table, which is the most interesting part for this session. So look how short and simple it is to create a route table. So all I say here is I want a resource of type /route table. And I'm defining a location here, which is going to be the region I'm going to deploy into. For today, I've used the region as US West. And in the properties, I kind of define the routes that go in the route table. So I just have one route here. So if you see that, I'm giving a name to this route. And then I'm actually defining the address prefix. So this address prefix is actually the address prefix that will be applied for this route. So meaning this is the destination prefix. So the packets that is coming out of a virtual machine that's using this route table, if the destination address matches this address prefix, then this action will happen. So that's the address prefix. And here I'm saying the value is subnet 3. So because if the packet is going to subnet 3, I want this route to take effect. And there are 2 critical things that I need to define. One is the next hop type, other is the next hop IP address. So the next hop type I'm saying is a virtual appliance. A virtual appliance refers to a virtual machine running in Azure. That's what it means. So I'm saying if you see a packet that's destined to subnet 3, send it or route it to a next hop type of virtual appliance, and the real address for the virtual appliance I'm giving over here as a next hop IP address. So this is a variable that I've defined called NM private IP address, NVM private IP address. You will see that I'm using it in one of the interfaces. So I'm just saying any traffic destined to subnet 3 goes to this IP address. That's all I'm saying in this route table. And you saw that in the previous section in the virtual networks, I'm attaching this route table to this subnet 1. So subnet 1 has this route table with variable route table name. That's a route table I created over here. So I'm attaching that to that particular subnet. So the last part is now defining the network interface cards and the virtual machines into the virtual network. So here I have 3 network interface cards because I have 3 virtual machines. So I need 3 network interface cards. So you see the NIC1 is going to be like a regular network interface card. It has a public IP address. It belongs to subnet 1. That's all about it. So I created a network interface. I created another network interface, and this is the interesting network interface because I'm going to be using this network interface on the virtual appliance. So this network interface does have a public IP. It belongs to the virtual network. It belongs to subnet 2. And here, look at this. I'm assigning a private IP address for this virtual machine. That's the NVM private IP address. I'm assigning that over here, the static private IP address. And I'm enabling IP forwarding for this for this NIC. So I'm saying that this NIC is going to behave like a router, and I'm enable IP forwarding is true, is what I've done here. Then I also, to round it off, I have another network interface, which is of NIC 3, which is going to be in subnet 3. This is for the backend VM. Nothing more special here. It's going to have a public IP address, and it's part of the subnet 3. Then finally, I define my virtual machines. So I have my virtual machines defined over here. So you see that like I have a VM1 with NIC1, and I define username, password to access that. It's the same. The image, if you see, I'm using the same image on all 3 VMs. It's going to be the Windows image. So the next one, I'm actually calling out VM2, and then that's going to have a NIC2, and the last one is VM3, and that's going to have a NIC3. So our VM2, which has the NIC2, is the one that is going to behave like the virtual appliance. The VM3 that has a NIC3 is going to be a VM in the backend subnet. So this template, you can just deploy it to Azure, and once you deploy, you will have something like this. If you go to the resource group, I have deployed this under a name called route demo. So if you look at, if you just take the template I showed you, and if you just click to deploy into Azure, you will actually get these resources created for you. So I do see 3 virtual machines, 3 network interface cards, 3 public IP addresses, and just to show all the resources, it also has a virtual network, has storage account and all those things, but here's the most important thing. It has a virtual network, it has public IP addresses, the network interface cards, and the virtual machines that I created. Now, let's go into these virtual machines and see how they work. So remember, the VM1 is a front-end virtual machine. So if you go into that, and I have it already remoted in. So if you go into that, you'll see that the IP address for this virtual machine is a 10.0.0.4 that belongs to subnet 1. Then I'm going to go into the virtual machine 3 for a minute, because this is actually going to be your backend virtual machine. So if you do a IP config there you see 10.0.2.4. This belongs to subnet 3. And this is going to be the VM with the virtual appliance. And this has a 10.0.1.4, and this belongs to subnet 2. Now, first, I told you that I'll show you the default route in work. So this is the VM3, and if this VM wants to talk to the front-end VM, of course, the security groups have to allow that. But in fact, did the wrong one. So I want to actually ping 10.0.0.4. So it's able to talk to the front-end VM. There is no routes in play. There's only system routes in play. So if I do trace route to 10.0.0.4, you'll see that it's directly connected. It's not going through any kind of hops. It can see the other VM directly. Right. This is the system routes in effect. Now, from the other VM though, if you come to this VM, and then if you try to do a trace route to 10.0.2.4, which is the backend VM, you will see that this is actually going through a hop. So this packet actually will leave 10.0.0.4 and then will go to 10.0.1.4 before it reaches 10.0.2.4. So this is the routes that we have defined is taking effect. So we have successfully diverted the packet that is going to 10.0.2.4 to actually take a hop at 10.0.1.4. Now to actually show you a little bit more, a cool thing. So I'm actually going to go into this VM. I deployed Wireshark here. So I'm actually going to try and ping the VM3 from VM1, and I'm going to show you that the packets are coming over here. So let's start a capture. I'm going to start a capture. So continue without saving. So the capture is on right now, and I'm actually going to go to the VM1 and ping the backend VM. So I'm pinging right now, and in the meantime, if I go back to the other VM, then I can ask for IP.address equal to 10.0.2.4. That is actually, so you see that. So you see a source 10.0.0.4 sending packets to 10.0.2.4. That's actually coming through this virtual machine. This VM's IP is 10.0.1.4. But since this virtual machine is now the virtual appliance, it's seeing all the packets that's actually going between 10.0.0.4 and 10.0.2.4. So that kind of proves that this is actually in the path. There are a few things I want to actually show you. So this virtual machine was deployed in Azure with a network interface card where the IP forwarding was enabled. There is more things that you have to do in this virtual machine, which I did, which I'll show you. So if you go into the server manager, you can actually install a role called the routing and remote access. So this is a server role that you can actually install. So once you install that role, you will actually be able to then go here and then say, okay, click on this routing and remote access, and then that brings up this window for you. And if you go into the properties here, I have actually enabled this computer as an IPv4 router. So this is now behaving like a router. So whatever packet it sees, it can put it back on the network. That's how the whole ping is working between the front-end VM and the back-end VM, but it is going through or going via this virtual machine that we have here. You can actually, Windows by default gives you LAN routing, and you can also do NATing by default. So you can set up this machine also as a NAT machine, and you can actually do NATing. So you can have like a central NAT server in a virtual network, and you can set routes such that like all packets come to this machine, and you can do the NATing over here. So just one other thing that you could do. But this is super cool. So once you're seeing these packets going between one source and another source, if it's coming through you can take a number of actions, like filtering on packets, or logging this to an external service, or doing some kind of like firewalling, or doing NATing. So all of these options are open to you. And that's precisely sets us to the next part of what I'm going to talk about. So before I finish, so the template I showed you is available on GitHub. It's there in Azure Quick Start Templates. So this is the link to that. So if you go there, you can actually get this, and you can actually do a deploy to Azure, and you can have the same scenario that I showed you also work for you. So that should be something easy for you to just set up and play with. So what does user-defined routing actually really benefits us, or what is the real use cases, and why do we really need it? So you might have heard about force tunneling. So there are in a lot of situations where you do not want some of your virtual machines to directly talk to the internet, or you want to inspect every packet going out of this virtual machine. You can set a route that says 0/0, which means any packet going out of this VM should do a next hop to a virtual appliance, and you can specify the IP address of the virtual appliance, just like I showed you in the template. Instead of the address prefix, destination prefix being a particular subnet, you can just say 0/0. That will force all packets from this VMs to go through the virtual appliance, at which point you can then choose to do whatever, NAT, or drop the packets, or do more logging or whatnot. So that's one commonly used cases that I want to highlight is force tunneling, which user-defined routes lets you do that. And the main play though here is a vast majority of appliance vendors who can now build their services on top of such platform functions. So in your on-premise networks, you probably have a lot of different network appliance vendors who probably offer things like firewalling or NATing or security related services for you. You can actually use those same appliance vendors also on the cloud. And these vendors are actually building their applications or services in Azure on top of features like UDR. So to get a full sense of all the vendors that we are working with currently, this is a list of those people. So some of these vendors here are offering like advanced application delivery control, kind of a load balancing, layer 7 load balancing solutions. Some of them are actually offering like advanced firewalling abilities, and some of them are offering more logging capabilities. So you can use whichever vendor, whichever appliance vendor that is actually certified in Azure. You can use one of them, and these vendors are on building the solutions on top of features like user-defined routes. So just putting it all together. So going back to the first slide. So in Azure, we are trying to provide a mechanism for you to have the same level of control and functionality that you will typically have in your on-premises networks. And the starting point of that is a virtual network. So once you have a virtual network defined, and once you have your subnets defined, and then next step, you can define the security policies through NSGs, or you can define the traffic flows using user-defined routes. And then you can actually do load balancing using Azure's load balancer, either for external load balancing or for internal load balancing. And you can also connect these back to your on-premises using things like ExpressRoute or site-to-site VPN devices. So this kind of holistically puts together the full list of things that you can do with Azure's networking abilities. And as a recommendation, I would always say that try to define your network and subnets before you do your deployments. So this way you can define policies like security and routing on the subnet level, and all the virtual machines that you deploy on the subnets will then inherit these properties, and you wouldn't have to go and do this every time that you deploy a virtual machine. There are some references, related services that is available to you that you can read in Azure.com, or lot of videos that you can actually watch. So hopefully you enjoy this session, and hopefully you'll tune into for more such content. Thank you.